Part 2, Section 18E on Rules of Integration. What this part of the lesson focuses on is how to figure out what the constant of integration C is. So the way that we're going to accomplish that is you're going to be given the derivative. So if you integrate that derivative, you're going to get what the original function is. The original function is the antiderivative of this. So when I do that, I'm going to end up with the original function plus some constant. Once I have that equation, then I'm going to be able to set the equation. The y is going to be equal to 2. So once I get to that, I'm going to set the equation equal to 2, and I'm going to substitute 0 for x. All right. So let's take this, we'll integrate it. So I'm just going to break it up into 3 integrals. That 2 is a constant, so I can pull it out front. All right, and then when I integrate this, this is going to equal the function. So the integral of x cubed is add 1 to the exponent over 4 minus 2, add 1 to the exponent, plus 3x. Okay, now this right here is the original function. So to figure out what C is, I'm sorry, I left the C off. Okay, I'm going to substitute now. I'm going to set this whole thing equal to 2, and then I'm going to put 0 in for the x. All right, so that's going to look like this. This whole thing's going to equal 2. And then wherever I have an x, I'm going to substitute in a 0. So my constant of integration is equal to 2. And my original function now right? So if we integrate this, the integral of that is going to equal the original function. So I could write it like this, okay? The original function, f of x, is equal to the integral, and we'll just split this up while we're at it, okay? So for the sine part, that's 2's a constant, so I can pull that out. This I can rewrite as x to the negative 1/2, or excuse me, x to the half. Okay, and then when I'm done solving this, I'm going to put 4 in for f of x. So that's going to go in for this. And then I'm going to put 0 in for the x value. All right, so now let's integrate. Okay, our integral of sine is negative cosine. So this is going to become negative cosine x minus, now I add 1 to the exponent, that's 3 over 2 over 3 over 2. Okay, let's simplify that second term. So dividing by 3 over 2 is the same as multiplying by 3 over 2, or 2 over 3. Plus some constant. Okay, now what we're going to do is take out f of x, put 4 in its place. And then wherever I have an x, I'm going to substitute in 0. And solve that for c. Okay, the cosine at 0. So we got our unit circle. Okay, at 0, on the unit circle, the coordinates are 1, 0. So this is the cosine of 0, and this is the sine at 0. So I can take this out. That's equal to a 1. So that's going to be negative 2 minus 0 to the 3 halves, 0. And 2 times 0, 0. So this whole thing turns into a 0 plus c. Add 2 to both sides, and I get c is equal to 6. And then our original function plus 6. Find f of x given that the second derivative is equal to 12x squared minus 4. This point is on the first derivative, and this point is on the original. So we're going to have to integrate twice. So if I integrate this second derivative, this integral is going to give me the first derivative plus some constant. And then we're going to use this point that is on the first derivative to figure out what that constant is. Then we're going to integrate this and use this point to get what the constant is for that integral. All right, so here we go. First, our first derivative is equal to the integral of our second derivative. So we'll just break this up. Got a constant All right, now from that point, we're going to substitute -1 for the first derivative, and 0 for x. Now, my first derivative now that I know what c is, now we'll integrate that, and it'll get us to what the original function is. Okay. Now we go back to the point that we were given, 1, 4, and I'm going to substitute 4 for f of x. And I'm going to sub 1 for x, and then solve for c. And therefore our original function is going to be plus 6. And that's how you find the constant of integration. It requires that you know a point on the antiderivative of whatever function you're given. All right, that's it for today. We'll see you next time.